Hello, and welcome back to Ships to Costa. Today, we're going to learn about one of the most important factors that will drive the decisions in your life: compound interest. Today, we're going to learn about compound interest, and we're going to learn what is the difference between that and simple interest. And we're going to also explore the connection between compound interest and exponential functions. By the end of this, you should have determined through investigation that compound interest actually is an example of exponential growth. You'll compare simple and compound interest with a table of values and a graph, and then you'll be able to solve problems using a scientific calculator that involve the future value of an investment that grows with compound interest. Start off, maybe pause the video here and see if you can answer this question very quickly. You realize that a situation like this, where you're borrowing money at a simple interest rate, is telling you that you need to use the simple interest formula, where 12% is the rate, $5,000 is the principal, or the value that the loan is worth at the very beginning, and 1 year is the term. And those three variables will get slotted in right here, and we will calculate the amount that you owe as A. So this would be 5,000 times 1 plus 0.12 times 1, which means the loan that we took, the $5,000, that's going to grow by 12% after 1 year. The size of it is going to go up by 12%, so we could just multiply it by 1.12 to get 5,600.
So now let's start our investigation for this lesson. So Frank needs $5,000 to start his company. He borrows it from a bank at an annual rate of simple interest of 12%, but after 1 year, he has no money to pay it back. And then in order to pay the bank back, well, he just goes to a different bank and says, hey man, can I? So we know that, just because of what we just did, we know that his debt of $5,000 grew by $600. He needed to pay back $600 in interest after the first year. And just because of our understanding of simple interest now, we know we can multiply this by 1.12 to get 5,600. He needs to pay this back to the first bank, and he doesn't have the money. So he goes to another bank and borrows $5,600, and he pays the first bank back. Good for him. But after the second year, he still has yet to make a profit. He actually owes more money. He doesn't just owe $5,000, he owes $5,600. And so he goes to a third bank and again borrows another amount of money. How much money would he have to borrow to pay back this loan? Remember, he owes $5,600, but it grew at the same rate. It grew by 12% as well. So how much money does he have to pay back? So what happened here, just before we get to our answer, what happens here is we took the interest and we added it to the principal and we created a new principal. When you do this, Frank is now going to start paying interest not on $5,000. He's going to start paying interest on $5,600. He's going to pay interest on his debt and on the first year's interest. When you do this, when you add the interest to the principal to create a new, higher principal, this is what's called compounding. To compound means to put together, like compound words, right? Like the word bittersweet is a compound word meaning bitter and sweet. This is compounded interest. We took the principal and we added it to the interest. So you might say, oh, so he's got to pay back another $600 in interest because you're seeing the $600 here. But unfortunately, it's going to be higher because 12% of 5,000 is $600, but 12% of $5,600 is going to be more. In fact, he will have to pay back an extra $672, right? This is 12% of 5,600. So this amount is actually a bit larger. And if I want to find out what is his total amount that he has to pay back to these guys, what I can do is take 5,600 and the same thing, I can multiply it by 1.12 to get $6,272. Now this is the amount that he borrowed from the third bank to pay back the second bank. And Frank's problems are just getting bigger and bigger, right? He doesn't just have to pay back the initial amount he borrowed, 5,000. Now he's got to pay back over 6,000. But at the end of the third year, how much money does he have to pay back then? This $6,272 is also growing at the same rate. Again, all we have to do is find out what is 12% of his debt. And when we do that, we find out that he's going to pay another $750 in interest, $752.64 specifically. So when we add these together, now he has to pay back $7,024.64. And the way we've got these numbers, where we can take the original principal and multiply it by 1.12. That is 112% to find the new amount that he owes. And then if we want to add the interest to find out this amount, again, we just multiply it by 1.12 again. Now we're taking 5,600 and multiplying it by 1.12. And now we're taking 6,272 and multiplying that by 1.12. So whenever we're trying to make up an amount, a debt, or an investment grow according to an interest rate, we can multiply that number by 1 plus the interest rate for that period. And if it continues growing for many of the same periods at the same rate, we can just continue multiplying by 1.12. So for this part of this investigation, I'll ask you in just a second to pause the video and complete this table. But what you're going to do is find the amount of a $10,000 loan after 10 years. If it grows at 12% per year and it compounds every 6 months. So we're going to fill out the table to find out how much would we owe after the 20th period. Remember, it compounds every 6 months. It doesn't compound over the full year. So what I'm going to do just to help us start off is use that idea of simple interest. So each period we take the principal and we multiply it by 1 plus RT. The interest rate is 12%. That's R. The term every 6 months, that's not even a full year, right? How many years is 6 months? Half a year. And so we would not get the full 0.12 times 0.5 is 0.06. We would not get the full 12% growth because we did not wait a full year. Instead, we would only get 6% every half year, every 6 months. So after 6 months, which is one period, a period is an amount of time. So after the first period of 6 months, we take 10,000, that's our principal, and we multiply it by 1.06 to find out that we now owe $10,600. After the next period of 6 months, again, we can do the same equation except our principal is going to change, right? Our principal is $10,600, but again, we will multiply by 1.06 to get $11,236. To find out how much it will be after 3 periods, I can take this number and multiply it by 1.06 to get $11,910.16. So pause the video right here, fill out this table, find out how much it would grow to if we did not compound. So in other words, use the simple interest formula to find out how much it would grow to after 10 years, and then plot both of those on a graph both of those situations. And this should take you about 10 or 15 minutes. So hopefully you were able to complete this by now. And if you haven't yet, then of course feel free to pause and keep going. But this is what I got. So I recognize that every time one period of 6 months ends, my amount, the amount of this loan grows by 6%. So I just need to multiply by 1.06. So I did that 3 times so far. I'm going to do it another time to find out after 4 periods of 6 months. So this is after 2 years. And then times that again and again and again. And I'll just keep doing this until I've completed 20 periods of 6 months. And 20 periods of half a year each is a total of 10 years. So I finally will end up getting, my loan will grow after 10 years to $32,071.35. Now, if I didn't, this is the end of question A, right? This is how big my loan is going to grow after 20 periods, after 10 years, if it compounds every 6 months. But how much would it grow to if it did not compound? So using the simple interest formula, I will still keep this the same, except my rate is the same, the principal is the same, but my term is the full 10 years. So I don't need to do this 6% every single time because it's not compounding. It's not growing by 6% every 6 months. It's just growing by 12% of the principal, of the original amount every year. So $12 for every $100, and it does that for 10 years, which would give me $22,000 flat. Now notice the difference between these two. Just by compounding it every 6 months, the interest rate was the same, but just because we compounded it every 6 months, it grew to more than $10,000 higher than it would have if it did not compound. This is the power of compound interest, and I'll show you another when I graph these, and hopefully you've graphed it already and you're already seeing how much these are different. But before we do, let's just take a look at and see how would we calculate this amount without having to do this entire table, because we don't want to do this every single time, right? Notice that we're doing the same thing. We're starting with our principal, 10,000, and we're multiplying by 1.06 again and again and again and again and again. And what is it? What operation are we doing when we are repeatedly multiplying by the same number? It's exponentiation. To get this number, I started at 10,000 and I multiplied it by 1.06 20 times. And that got me 32,071.35. In fact, if you put this into your calculator, you will find out that that is exactly the number you get. This is the formula for compound interest, and we'll dissect this in just a second, but before we do, let's graph both situations. Your graph should look something like this. So here you see simple interest growing in a nice straight line. Every year you get charged the same amount of interest. So every year your loan grows by the same amount. It's just $1,200, I believe, every single year for 10 years. But with compound interest, your loan grows like very similarly, very slowly at first, and then it starts to speed up. And now it's getting even faster. It's growing faster and faster and faster. And if you recall, exponential relations work exactly like this. They start off by growing slowly, but then they very quickly speed up and they start growing faster and faster and faster. And so this, if we look at the number of periods, which is in the exponent, 20 periods, that is the exponent, we recognize that compound interest grows exponentially because the independent variable is in the exponent. And that means it grows slowly at first, but it grows faster and faster and faster over time.
When we're dealing with debt, in other words, when someone borrows money, the amount that they borrow is going to determine how much they pay in interest, which is a fee for borrowing it. And that's always given to them at the beginning as a percentage rate of how much they're borrowing. But every so often, just like we saw with Frank, the lender will do something called compounding the interest. What does compound mean? Well, just like you have compound words like bittersweet and butterfly, or compound molecules in science like sodium chloride and sulfuric acid that combine two molecules into one compound. Compound to compound interest means to combine then, right? So here we're combining two words to make one word. Here we're combining two particles to make one molecule. And with compound interest, you're combining the interest that is owed so far to the amount that was borrowed at the start, the principal. And now you're going to charge interest as if the whole thing together is money borrowed. What that's going to do is the debt that is borrowed is actually going to grow by a percentage every single time, not by a very specific amount like simple interest does. So if we wanted to grow $10,000 by 6%, we would always just multiply, okay, what is 100% of 10,000 and 6% of 10,000? And we could add that together to say, what is 106% of 10,000? We can grow the principal by the interest rate, right, by 6%, just by doing P times 1 plus I. And if we wanted to grow that again, if we're borrowing it, for example, for another entire period, if we need to grow it by 6% again, or by I again, we can multiply it by 1 plus I again. And if we want to grow it for 3 periods, we would do that again. Or if we want to just keep going again and again and again and again, for n periods, well, we would just keep multiplying by 1 plus I, a total of n times. Now notice over here, this formula, we've started with the principal, we've grown it by I% n times, so we're always multiplying by the same number n times. This will therefore be an exponential relationship. We could just say P times 1 plus I repeatedly, a total of n times. And that right there is the formula for compound interest, for the future value of a principal that is grown by I as the interest rate per period for n periods.
So when you add the interest of a loan or an investment to its principal to create a new principal, what are you doing? You're doing something called compounding the interest. To compound means to put together. Compounding interest makes a principal grow a lot faster than simple interest like we saw in that graph. When you're given an annual interest rate, which is R, and a term, which is always an amount of time that's expressed in years, that's T, we can use the simple interest formula, which is pretty easy. But later on, you might be given something called a compounding frequency, which we're going to use the variable f to denote frequency. That will tell you how many periods there are in 1 year. So for example, if it compounds annually, that means it compounds every single year. So the frequency is 1 period in 1 year. If it's semi-annually, that means it compounds every 6 months. And that means that the frequency is 2. There are 2 periods of 6 months in a year. If it compounds quarterly, there's 3 months. It compounds every 3 months. And how many periods of 3 months are there in a year? 3, 3, 3, 3 makes 12 months in total, so 4 periods. If it compounds monthly, there's 12 months in a year. If it compounds weekly, there's 52 weeks in a year. And if it compounds daily, that is 365 days in 1 year. So we can find out what is the interest rate for 1 period per period. And that's different from the annual interest rate. The annual interest rate is the rate for a full year. But if a period is only every 6 months, then just like we took 12% and divided it by 2 to get 6% for 6 months in our investigation, we take the annual interest rate and divide it by the frequency to find the interest rate per period. And we're going to use the variable I to signify the interest rate in one period. If we want to find out how many periods there are in the entire term, just like we took 10 and multiplied it by 2 to get 20 periods in 10 years, to find out the number of periods, we'll use the variable n for number of periods. We can take the term, the number of years, and multiply it by f, because f is the number of periods per year. So if 1 year has 4 periods and we're doing this for 15 years, 4 periods per year times 15 years would give you 60 periods in the entire term. And each period has its own interest rate that's different from the annual interest rate. So the formula is to calculate the total amount of a loan. If it's growing with compound interest, we're going to use this formula, P times 1 plus I to the power of n. P is still the principal, that's the amount that you borrow at the start of a loan or at the start of an investment. I is not the interest rate, it's the interest rate for one period. And the way we calculate that is we take the annual interest rate divided by the frequency. N, the exponent here, is the number of periods. And so we take the term, which is the number of years, and multiply it by how many periods there are in each year. And that's how we find N. And then we can use this formula pretty easily to calculate the total amount at the end of the term. If we want to find out how much of our loan is just interest, all we have to do is take this future amount and subtract the principal, the amount that we borrowed in the first place. And we would find out how much interest are we paying in total on this loan. In this example, on August 7th, 2004, Google first began selling shares to the public. Remember, a share is like one tiny piece of a company. So you could own a piece of Google for just $2.71 in 2004. Every year, on average, Google grew. It became more and more valuable as a company. And the price of one share increased by 57% each year on average until 2023. So if you bought $100 worth of Google shares at its initial public offering, its IPO, in August of 2004, how much would your shares be worth now? So if we want to calculate the total amount of a loan or an investment that's growing with compound interest, remember we're going to use this formula here, okay? So P is the principal, that's $100. That's how much you invested in 2004. So that is $100. But if I want to find out the interest rate per period, I know that it grew 57% each year. So the frequency is 1. The frequency is there's one period each year because we're only talking about annual growth here. And if the frequency is 1, then these two equations are really easy, right? The interest rate for one period is still going to be 57% divided by 1. Because one period per year, we don't need to divide this at all. The interest rate is just going to be 0.57. That's 57% as a decimal. In 1 year, because 1 year is one period here, it only grows annually, it's going to grow by 0.57. How many periods are there between 2004 and 2023? Well, if each period is a year, I'm really asking the question, how many years between these two? And I could just subtract them to find 19, right? The difference between these two is 19 years, and 1 period per year would give you 19 periods in total. And now that I have all three of my variables, the principal, the growth rate per period, and the number of periods, I will just use my compound interest formula. So this is 100 times 1 plus 0.57 to the power of 19. I would encourage you to pause the video here and evaluate this on your own. Find out how much what is the amount of your shares. Remember, you bought $100 worth of shares in 2004. If you want to sell them in 2023, how much would they be worth? Well, to evaluate this formula, the first thing you do is 1 plus 0.57, right? You always do brackets before you do anything else in your order of operations. So that's 1.57. And then you do the exponent before you do anything, before you multiply. BE, exponent is next. And this gives you $527,343.26. And if you're saying to yourself, hold on, I must have done something wrong, there's no way that my $100 grew to $500,000, you're absolutely wrong. Like that, there is a way, and that is the power of compound interest. Growing by 57% each year means it's growing by a larger and larger amount every single year. It's growing exponentially. And you could sell those $100 of shares that you bought in 2004, you could sell them in 2023 for over $500,000. This is how people save so that they can retire. They invest in companies. They don't just put their money in a bank account, because when you just leave your money in a bank account, the cost of living each year goes up by 2%. And so even if you bought $100 worth of stuff in 2004, you cannot buy the same things with $100 in 2005 because things are more expensive. And you can buy even less in 2006. So you can't just keep your money under your mattress in your house, or you can't just keep it in a checking account in a bank. You need to put your money somewhere where it will grow with interest. Now, it doesn't have to be 57% interest. This is really extremely high. It's unrealistic that something could keep this up over such a long period of time. Although Google certainly has. This is actual real data, right? So you have to make sure that you're investing really, really wisely. What if you took a loan? How much interest would you pay on a 4-year loan of $15,000 if it grew at 6.8% per year and compounds semi-annually? Well, to find out the total interest, we need to know how much is our loan worth at the end of the 4 years. And then we have to subtract the amount that we borrowed just to find out how much interest we're paying. And so $15,000 is our principal. Our interest rate per period, remember, this is compounding semi-annually. That's every 6 months, if you refer back to that table. And so the frequency, how many periods are there in 1 year if one period is 6 months? The frequency is 2, because there are 2 periods of 6 months in a year. So the interest rate for one period per period is not going to be 6.8%. It's going to be 6.8% divided by the frequency. So 0.068 as a decimal, just divide by 100. And then divide that by 2, because we have to divide it by the frequency, gives us 0.034. So the interest rate for one period of 6 months is 3.4%, not the full 6.8%, because we did not wait a full year. How many periods are there going to be in 4 years? There are going to be 8 periods, right? Because each period is 6 months. And so there are 2 periods in a year. And 2 periods times 4 years, that's our term, is 8 periods in total. And when we use our formula, P times 1 plus I to the power of n, I is 0.034. We will add that to the number 1 to get 1.034. And then do 1.034 to the power of 8 times 15,000, and that would tell us that our loan has grown to almost $20,000. Now, how much interest did we pay? This is how much we have to pay back, but this includes the principal. So all we have to do is take $19,599.98 and subtract the principal of $15,000 to find out that the interest we paid is $4,599.98. You have to repay $19,000, of which $4,000 will be just interest.
save up for their first year of college, which will cost $2,686. 11 wants to invest some money in grade 9, and this is 4 years before they will actually go to college. To do that, they find an investment product that will guarantee them 2.7% per annum, which means per year, and it compounds every week. Question is, how much should they invest today in grade 9 so that in 4 years, when they go to college, they will actually have this money? Whenever you're dealing with an amount that is growing with a loan or an investment, it's growing with compound interest, this is the formula that we use. A is the amount or the future value, which we know in the future, Levin needs this loan or this investment to be worth $2,686. We also know that this situation compounds every week. So before we can find the interest rate for one period, which is 1 week, it's not going to be 2.7%. That's per year. We have to divide that 2.7% by 52 because that's the frequency. And that I'm just going to leave that as a fraction here because I don't want to round it at all. So I'm just going to leave it like this. That is the interest rate for one period. Now, over the course of 4 years, I know that there are going to be, n periods. If there's 52 periods in each year, 4 years times 52 will tell me that there are 208 periods, 208 weeks in 4 years. So now that I have the values for 3 out of the 4 variables, I can plug those in here. So the amount is 2,686. The interest rate is this fraction. Then that's per period, per week. There are 208 weeks, and I only have one unknown variable. And the way I can find out what the value of this unknown variable is, I need to get rid of all of this part right here. And I could evaluate this on my calculator, and it will give me a number. And then I'll need to multiply p by that number to get this. Well, let's say that number was something easy like 5. P times 5 gives us this. To isolate p, I would divide by 5. So to isolate p right now, I'm just going to divide by this entire expression. Whatever number that's going to be, it's going to cancel itself out anyways. And because I changed one side of my equation, I also need to change the other. So I'll divide this side by that expression as well. And when I plug all of this into my calculator, I will find out that the value of P is $2,411 and 0.095. Now I need to round this to the nearest dollars and cents. And so I'm going to round it to $2,411.10. If 11 invests this in grade 9, they will have enough. It'll grow by 2.7% per year. It'll compound every week. And for 208 weeks, it will do that. And eventually it will grow until they have $2,686.
Determine how much money you will have if you have $500 and you invest it for 6 years at 4% per year, compounded semi-annually. So this question is very similar to the example number 2, but what I'm going to do here is I'm going to show you a diagram of what's happening. So if this is your term, you're investing this for 6 years, so that's 1, 2, 3, 4, 5, 6 years, and you're starting with $500. How much would this end up being? Well, it's compounded semi-annually, which means there are 6 months in one period. So the first year has 2 periods, the next year has 2 periods, the next year has 2 periods. In total, we have 6 times the frequency, which is 2, 12 periods in total, right? N, the number of periods is 12. Now we're getting 4% per year, but we're not waiting a whole year before we compound. So how much are we getting in just one period? 4% divided by the frequency, which is 2, is 2%. And so $500 is growing by 2%, and the way we do that is we multiply it by 1.02. And it's $510 after 6 months. And then we can multiply it by 1.02 again to find out how much it is after 1 year. And we can keep doing this, just multiplying by 1.02 again, until we have done this a total of 12 times to find the amount. So the amount is 500 times 1.02 to the power of 12, which is approximately $634.12. This is what that looks like on a graph. If this were to grow with just simple interest, we would end up with $620, but because we've compounded, it's gotten us $14 more. Now, this doesn't seem like a lot because the interest rate is quite small, and it's not compounding really frequently at all. It's just semi-annually. The higher the interest rate, the more frequent the compounding, the faster it will actually grow.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.